Hey everybody, it's Tracking Pat. In today's video I'm going to do a sample of a part that seems to be circling around the internet. I've seen multiple people show how to make this piece part, and it's a pretty simple flat part. Now I've seen it designed in everything from CAD using CAM, I've seen it done in straight up G-code, I've seen it done in other people's controls, and everybody claims that their way is the best way. As we all know, when it comes to simple parts like this that have some complexity, nothing beats a ProtoTRAK, especially when you're making prototype parts and only need one. I can tell from looking at this print right away that it doesn't have all the information, but I'm smart enough to know that the AGE programming will actually be able to figure out anything that's missing. So what I'm going to do is get us started by showing you how I would make this piece part. So first thing I'm going to do is go to the program mode. I'm going to give it a name. I'm going to call it sample number 1, and then I'm going to swipe forward. First thing I'm going to do is the upper hole in the left hand corner, so I'm going to go to drill and I'm going to say yes, I want to drill. My first position is at 0.15 and minus 0.15. I'm going to use a rapid plane of 50 thousandths and make my Z go minus 0.1 because I'm only center drilling. I only need one peck. I'm going to do this at 1800 RPM, 5 inches a minute with tool number 1. Now one of the great features with the RMX is that I can simply swipe back to that original event, and then I can go to the options page, and in the options page the last button down here says would you like to make multiple holes. What this does is populate each hole position that I'm about to give with all the information I used in my first event. So now I'm going to fill in just the rest of my holes. So my second hole is at 1.15 and minus 0.3. My next hole is at 2.85 and minus 0.3. Next hole is at 3.85 and minus 0.15. The corner hole is at 3.85 and minus 1.75. Middle hole is at 2 inches and minus 1.216. And the final hole is at 0.15 and minus 1.75. Now what you're going to see happens is when I hit the complete button here, you see all my holes are already here in the look screen. And as I swipe forward, you'll notice that each one of these drilling events is exactly the same, only in different locations. So the next thing I'm going to do is, now that I've got them center drilled, I need to drill them through. So I'm going to go to copy and repeat. This will allow me to make new events where I can alter some of the things that are in them. So I'm going to repeat everything, which is from event 1 to event 7. I'm not going to have any offsets except for I want to go another 700 thousandths deep to get through the part. I'm going to do all of this one time. I'm not going to change my feeds or speeds, but I'm going to go to tool number 2. And as you can tell now from this number up here, I've got 14 events now, so half of them are the new events. Next thing I'm going to do is I'm going to switch modes. I'm going to go to edit mode and I'm going to go to search edit. The search editor is a spreadsheet editor that allows me to make global changes really quickly instead of changing them one event at a time. So I'm going to go to my first drilled through hole. I'm going to select change all, and I'm going to change this to 2000 RPM. Next I'm going to click over here where my feed rate is, and I'm going to change all, and this time I'm going to change that to 4 inches per minute. And last I'm going to come over here to my pecs, hit change all, and I'm going to put 8 pecs in there to get all the way through the part. Now that I'm done, I'm going to hit return, go back to the program, and I'm going to use copy one more time, but this time I'm going to select the drill to tap function, and this allows me to turn drilled holes into tapped holes. So I'm going to take those same holes from 1 to 7, and I'm going to put a different Z rapid in here of 0.25 so that I got enough clearance for my floating tap head. And then my Z depth, I'm going to go minus 5/8, so 625. The pitch is what I don't know, so I'm going to go to my calculator because I know I've got a 3/16 24 thread that I'm trying to create, so I'm just going to say 1 divided by 24 equals, there's my answer, and I'm going to hit the abset button, and that puts it right here into my program. Close the calculator, put in my 300 RPM, make this tool number 3, and all of my drilling is complete. The next thing I see on this print is that there's a section right here that my end mill is going to leave standing when it cuts around this profile. So I need to get rid of that first. So I'm going to go to profile, and I'm going to use a regular profile, and the reason for that is because with a regular profile I have the ability to have multiple cuts in the Z-axis, and since I got to go a ½ inch deep, it makes sense to do this. So I'm going to start in the center of my part, which is 0.2, and then we're going to go negative 2.25, which will get me off the piece part to bring the tool down. My Z rapid, I'm going to keep it at 50, and my Z end, I'm going to go minus 0.5 like I said. My tool, I'm going to change the center so that it plunges straight into the part. I'm going to do this in 4 passes at 1800 RPM, and I'm going to put my feed rates at 10 inches for both the Z and the machining feed rate, and I'm going to use tool number 4. So you'll see there's a little blue dot right here that says this is where I'm going to start. Now I'm simply going to say it's going to be a straight line. I'm going to use ink set or no change for the X dimension, and the Y I'm going to end up at a minus 1.7, which makes me stop just short of that bottom radius. You see I have an OK right there, so I'm just going to swipe forward, push End AGE, and my first profile is complete. Now for this profile that goes around the outside of the part, it's going to be a little bit different, but the process is the same. So I'm going to go back to a regular profile. I want to start off the part, so I'm going to start at a minus 0.3. I'm going to start at Y0, same Z rapid, same Z depth. Okay, I'm going to keep my tool on the left because I want to climb mill this. I'm going to use 4 passes again. I'm going to leave a finish cut of just 5/1000. And then my RPM is already in here. I'm going to put it in the final cut as well. I'm going to use those 2 feed rates, but I'm going to add, make sure that all of my feed rates are correct, even my finished feed rate. Okay, so I got them all at 10 inches per minute. I'm using the same tool for both my rough and my finish pass, which is going to be a 3/8 end mill. So now I've got this dot out here that says this is where you want to start. And the next thing I'm going to do is select a milling event. So my milling event ends at 4 inches, which is the length of the part. My Y dimension stays at 0, and you see that I have an OK already, which says that's all I need to know. But it's offering me the chance to put a radius on the corner, so I'm going to put 10/1000 in there just to knock off the edge of the part. So next thing I'm going to do is swipe forward, do my next milling event. It is not tangent because 2 lines cannot be tangent to one another, right? There has to be an arc involved. So I'm just going to leave that at no, and I'm going to say ink set or no change for the X dimension. And the Y dimension, I'm going to go to the width of the part, which is 1.9. You'll see I have my OK there. I'm going to put in that 10/1000 radius for the corner again and swipe forward. Next milling event, I'm going to come in here, and this time I don't have the X dimension. I know it's somewhere around here, but it's not on my print, right? So I'm going to use the guess feature, and I'm just going to click at about where it's at. When I hit the enter guess button, you'll notice that it filled in the X and the Y for where I had clicked. I need the X as a guess, but the Y I actually know is actually just ink set. Okay, so that straightens out the line. It shows a radius of 195. So I put that in there, and that's all I know, so I swipe forward. Here's where it gets a little funner. Now I've got another milling event, okay? I don't know where this one ends, so there's 2 ways I can do this. To show you how both ways work, I'm going to show you this way. I'm going to use the guess feature and say that it guesses somewhere around here. And then I'm going to push enter. Okay, now I'm going to tell it what else I know. There's no Conrad. I don't know the length of the line, but the line angle is actually at 135 degrees. The way that I get that is this is the beginning of the line and this is the end of the line. So if I start here, my 0 point in degrees is always at 3 o'clock. So here I'm at 0, here I'm at 90, plus 45 degrees puts me at 135, okay? So I'm just going to put the 135 in there. And then you see that you got a dotted line that's saying, oh, it's somewhere around here. And now I've got an arc, okay? In my arc, it is tangent to that line. So I'm going to click that button, hit the enter button, and now it says which way is the direction of the arc. It's going counterclockwise. So I'm going to change that to counterclockwise. My X and Y end, just like over here, don't work. So I could guess if I want, but you'll learn as you use AGE what you do and don't have to guess at, and it can always figure out a tangency point just because of the direction of the arc. So I'm going to leave it blank this time and just put in the center. So the center of the arc is at 2 inches, and the Y dimension is at a negative 1.65. Okay? There is no Conrad on this part, but the radius is 0.195. Okay, now I don't know how many degrees of arc there are, so I'm going to swipe forward. Now I've got another milling event. This milling event is tangent to that arc, so I click the button. My X end I don't know, but I can guess because it's somewhere around here, and push enter. And again, it fills in both values, but I'm just going to back up 1 and put in the actual number, which is minus 1.9 absolute. Put in my Conrad at 195. Okay. And then the last question that I know is the line angle. Now this time, This is the beginning of my line, and this is the end of my line. So again, 0, 90, 180 plus 45 equals 225 degrees. And as you can see, it figured everything out. My next piece is just a milling event. Okay, I'm going back to 0, and I'm going to keep the Y on ink set, or keep it where it is. I'm going to add that 10 thousandths finish to break the corner, swipe forward. Now I've got another milling event that's going to take me right to 0, 0, but I still want to have that 10 thousandths finish cut. So I'm going to put that in there and add one last line to walk off the part. This will allow me to put that radius right here at 0, 0. So I'm just going to say, hey, move over ½ an inch and up 5 thousandths, and then I'm going to swipe forward and push end. Okay, so there's the outside of the part. The last part I have is to do the pocket. So I go to pocket, and it's an irregular pocket, just like an irregular profile. The only difference is I have to end where I begin. Okay, but before I start this pocket, I'm going to make some other changes. So I'm going to go in here to my options page. And first of all, I'm going to change from RPM to surface footage. Okay, the next thing I'm going to do is I'm going to change from feed to minute, feed to tooth. And then I'm going to come down here and change my entry from zigzag to helical. And last but not least, I'm going to change from an offset toolpath to an adaptive toolpath. So now that I've made all my changes, I'm going to close that window, and I'm going to start out where I want to begin. So I'm going to be at 0.3 and minus 0.3 for the upper left corner of the pocket. Still going to use 50 thousandths there. My Z end, still going to be minus 0.5. And the number of passes, I'm only going to use 1 because I'm using adaptive machining now, right? So my finish cut here is just going to be 5 thousandths like I used before, but now I'm going to use my surface footage. So let's say I use 400 surface feet for both my rough and my finish. I'm going to use 3 thousandths per tooth for my entry and 6 thousandths per tooth for the roughing and 5 thousandths per tooth for the finish. I'm still going to use tool number 4 for both my rough and my finish cuts. This little green dot is showing me where I'm going to begin, and what I want to do is climb mill this pocket. So I'm going to do a milling event, and my X end is going to stay the same, so ink set, but my Y is going to go to a negative 1.6. Okay, you'll notice I have my OK, but I want to put in that radius again. It calls for that 195 radius again, and that's all I need to tell it. So I swipe forward. Just like before, I kind of got the same function going on here. I've got a milling event that I don't know where it ends. So I'm going to go guess, click on the screen, push enter. I only need the Y, so I'm going to say ink set for that. Put in my 0.195. Okay, and I'm all done there, so I swipe forward. My next milling event, okay, this is the one that's at an angled line. I don't know where it ends, so I'm going to leave it blank because I know it'll figure out the tangency itself. I'm going to come down to the last question. Now this time, this is the beginning of my line, and that's the end. So from 0 to there is 45 degrees. So just like the print shows, this time it actually is 45. Now I've got an arc, right? This arc is tangent to the milling event. All right? It is clockwise in direction, and I don't know where my X and Y end is, so I'm going to skip those again. I'm going to fill in what I do know, which is that the center is at 2 inches and minus 1.216. Okay, there's no Conrad on this, but the radius is 0.188. I'll put that in there and then swipe forward. My next piece is going to be a milling event again. It is tangent to the previous arc, so I click that button, put my X down here, which again I don't know, so I'm going to hit the guess button, click over there, hit enter. And then I'm just going to back up and actually put in that value, right, which is minus 1.6. And then the Conrad of 0.195. And last but not least, the angle of the last part here, this piece now being that being the beginning, that being the end, right? So 0, 90, 180, 270 plus 45 equals 315 degrees. You'll see that it's figured it all out there. I've got a milling event. X ends at 3.7. Y stays the same, so ink set. I'm going to put in my 195 radius, and I'm going to swipe forward. Got another milling event, just as simple as the last one. Ink set for the X. The Y goes to minus 0.3. Put in my 195 radius. move forward. Next milling event, I don't have the X again, but I see that it's going to run into that arc, so I'm going to say guess. Click about there, push enter. Back up one step, use the ink set key, put in my 195 Conrad, and swipe forward. Now I've got an arc. This time the arc is not tangent to the line. It is clockwise in direction. My X end I don't know, so I'm going to guess again. Enter. Back that up. Ink set. My X center is 2.850. My Y center is ink set, which would be the same as minus 300 absolute. There's a Conrad of 195 again. And then the radius of the actual arc is 0.313. You see that it figured that part out. Swipe forward. Whoops, wrong button. Milling event. Use the guess feature again, somewhere around there. Notice that all you got to do is be close to the right area. In reality, if there's two answers that can be evolved from the geometry, you have to be closer to the right answer than the wrong answer. So don't try to be too technical. Put in my Conrad right there. And actually, I need to back up a little bit because I forgot that this one can still stay at ink set. There's my Conrad. And the last thing I'm going to do is swipe forward. So now I've got another arc, just like the other one that I did. Direction is clockwise. Guess at the ending point, right there. And then back up and use the ink set key one more time. X center on this one is 1.15. Y center is ink set. There's a Conrad of 0.195 and a radius of 0.313. There it is. I got one more piece, so I swipe forward, hit mill, and I take it to 0.3 and minus 0.3 and fill in that last Conrad, and there's my completed pocket. So now I'm going to swipe forward here and push End AGE, and all of my programming here is done. The next thing I want to do is go up to my tool table and tell it about the tools. Now I've got tools already set up here in my library, although I don't have any offsets because I'm using offline. Normally if my tools were set up, each of these Z offsets would be filled in. But for demonstration purposes, this will work fine. So I'm going to use my 5/16 center drill. So I'm going to call that tool number 1. You see it implements it right here. I'm going to go down to the drills and I'm going to use this drill bit as tool number 2. I'm going to use this tool right here to do my milling, so that's tool number 4. And if I scroll down a little bit, I'm going to use my 3/16 tap as tool number 3. Okay, so I scroll back up here, you see all of my tools are correct in green. So I'm going to close that. Now I'm going to go to my setup mode. And in my setup mode, I'm going to check my tool path. So I go to the tool path, and what you're going to notice here is it's going to calculate all the information that I put in and create the G code automatically. In the ProtoTRAK, as you guys know, you're never going to see the G code unless you want to, and for the most part you don't need to, because right here is the tool path showing how to complete your piece part. Also notice up here that it says it's going to take 13 minutes to make that part, which is pretty quick, right? Now I could have changed one other thing in the way that this structure works. I have it cutting only in one-way direction, so I could actually change that too. So if I go back to my program, I could go to any part of this to figure out where I'm at, and let me show you the easiest way to do that. If I swipe backwards, there's a list step button in here, and my list step button actually highlights each piece of the program as I walk through each part, and you'll see as it's highlighting in this red color that I go through each piece. Okay, so there's my first profile, there's my second profile, and when I get to where I want to do my pocket right there, all I have to do is hit return. And here, if I go back to my options page, you'll notice in my options that I can also change the direction of cut. Right, so if I come down here and I look at where my actual direction of cut is, it's listed right here under one way, and I want to change that to zigzag. Okay, so I go to zigzag. Now if I go back to the setup mode, I just want to check and see if that makes it any faster in the process. So you see it shaves a little bit of time off it, maybe about 30 seconds or something like that. It makes it a little bit faster to cut it that way because it doesn't have to lift between passes. Okay, so now that I got that done, I'm going to hit return and I'm going to go to verify. Now when I use verify, I always like to change the numbers because the autofill for the numbers usually goes by all of my dimensions that are actually in my program. In reality, let's say I've got 100 thousandths all the way around this part before I cut the outside profile. So I'm going to go minus 0.1 for the X and then minus 2 inches for the Y. The Z bottom would be minus 0.75. And then 4.1 would be the long end of the part, and 0.1 for the Y positive. And then the top of the part will be Z0 because I've already faced it off. So push return here and I go to make part. And now you're going to see I'm going to slow this down a little bit. I'm going to make the part bigger so that you can see everything that's going on. And then I'm going to go to verify part. So you see here I'm doing my center drilling. Next I'm doing my peck drilling to drill through the part. I'm going to keep this on the slow mode just so you can see everything that's happening, because once it gets into adaptive machining it goes pretty fast. So there's my drilled holes. Next will be my tapping of the holes. That also happens pretty quickly. So there's my tapped holes. And now I do my first profile followed by my outside profile in all 4 passes and the finish cut. Next I'm doing a pocket, so you see my helix in to the final depth of 500, and then it starts to zigzag its way through the part. So here it's using about 30% of the cutter, and it's rapiding back and forth as fast as it can to cut that part out and keep the chip load constant all the time. So all the same features you get using CAD/CAM, only you didn't have to bother or even own a computer. And now once it finishes roughing out the pocket, you're going to see it's going to pick out the corners, and then it's going to go all the way around the outside to complete the pocket. There it is, picking out the final corners, right? Got a little bit there, it's got a little bit more to do right here. A little more down in the lower left. And then go all the way around the outside. And there you go. So as you can see, as it's completing the drawing here and showing me what I'm making, that everything in here is done completely. Okay? I didn't need a computer, I didn't need a CAD system, I didn't need anything but a piece part drawing. Now, I'm going to show you some other features, but first of all I want to just rotate this part a little bit, kind of show you so you can see exactly what it is that I built in here, and it looks correct. So I'm going to hit exit, and now what I'm going to do is I'm going to do another video in a minute, and I'm going to show you some other methods, because truthfully the ProtoTRAK is absolutely the fastest way to get from print to part. There's no doubt about it. Everybody can make their claims, but there's no doubt this is the fastest, most powerful control there is. And of course with the RMX and the touchscreen, we got some other features that are really great. Here you're watching me in my offline with my touchscreen laptop, so it works exactly the same way. And I just want to tell you that before I show you this next video, I want you to keep in mind that when it comes to a piece part like this, you have a lot of options, but you need to put the right amount of technology towards the type of job that you're doing. And in a case like this, the ProtoTRAK RMX is perfect for it. So I'll see you in the video, or in the next video, but until then, remember as always to keep on tracking. Thank you very much for watching.